Hi everyone, welcome to the next video. Last video we went over the while loop, and this video we will talk about a better loop. Before I get to that loop, I want to make a quick note. I don't believe that I mentioned precisely what this code does. So taking a variable that's a number and doing plus plus to lay it out explicitly, that takes the variable and increases it by 1. So every time this loop runs, we're increasing count by 1 each time. So it'll be 0 to 1, then 1 to 2, then 2 to 3, so on and so forth. So keep that in mind because we're going to use it in our next loop too. So the reason why you won't often see while loops used is because they're a little haphazard. And what I mean by that is they're simple. They only take a condition, and it's very easy to forget some sort of update to that condition. And we have to write that in the body of our loop, the body being inside the code block. And so most programming languages have a way to do that update inside the loop. And we do use a structure called the for loop. And so what that looks like is for, and then the for loop takes 3 things, and it's parentheses. So it's just a little more complicated. Those 3 things are a variable, declaration, and assignment that is going to be the iterator. So I stands for iterator, and by convention we just make that shorthand. So let I equal 0. The second piece that goes into the for loop is the condition. So that would be this part of the while loop, if we want to think of it that way. It's what we're checking to see if the loop should still run or not. So for let I equal 0, and while I is less than or equal to 100. And the last part is the update to our loop to get us closer to breaking out of this condition. So if we are going from 0 to 100, then we want to make I bigger in some way. And so you can do a myriad of things, but the most common thing you'll see is I++, meaning we're going to go 1 by 1 and loop 1 by 1. You could increase it by 2, you could increase it by 3, count by tens, you could even multiply this up. But the most common by far you'll see is I++. So once we've got the loop set up, it's very similar to the while loop, except now we don't have to update anything manually in here. The implementation of the loop that tells us, when should it start, when should it end, is all done in the context of these parentheses. So these 2 loops will do the same thing. And when you're using for loops, you want to keep in mind that you're declaring this variable I. That is going to be kind of the main power of your loop, right? There's no outside variable you declare. The I is what's going to represent which loop you're at. So you'll be using I inside the for loop in some context. So if we run this, we comment this out, we should still see a loop that prints 0 to 100. And there it is. So 0 to 100. But now we didn't have to declare this outside variable that represents our count. We didn't have to write some update inside of our loop body. It's all built into the parentheses. And so it's harder to forget that, hey, you need to increment this, otherwise you'll run into an infinite loop and crash your browser. So for the most part, 9 times out of 10, you'll reach for a for loop instead of a while loop. There are a couple of cases that a while loop might be better. More often in the case that you're looking for some sort of condition that's not necessarily a number. For instance, while the lights are on, do something. And then you just have something in the code that would turn the lights off. That's just a high-level example. So let me stress that I loops or for loops aren't just for counting up or necessarily down. You can do any amount of code in here. So as a common example of a fun coding challenge, if anyone's ever heard of the foo bar challenge, you basically log foo for any number that is a multiple of 3. You log bar for any number that is a multiple of 5, and then you log foo bar for any number that's both a multiple of 3 and 5. So if you were to write that in code, it would look something like this. We're comparing this against I. So if I modulo, so this character is modulo 5 equals 0. So what this says is if I divided by 5 gives a remainder of 0. So if we were to take 6 and divide it by 5, that would give us a remainder of 1, which means that number is not divisible by 5. It'll only be divisible by 5 if the remainder is 0. So if I modulo 5 is equal to 0, meaning it's divisible by 5, and I modulo 3 is equal to 0, meaning that it's also divisible by 3, we're going to console log foo bar. Else if I modulo 5 is equal to 0. So this is what this ampersand is doing, is saying, hey, this left condition needs to be true and this right condition needs to be true. If the left side is true and the right side is false, then this won't log. It's going to go to the else if. So let's say, for instance, I modulo 3 is true, but I modulo 5 is false. So we reach this else if block. This will also be false, but just in case it's true, we're going to log bar, because that's our condition. If it's only divisible by 5, we're going to log bar. And then we're going to check else if I modulo 3 is equal to 0. We'll console log foo. And finally, if none of those are true, we'll just log the number I. So you can see that for loops don't just have to log numbers. We can do any amount of code we want in them. So this is a very common computer problem, just as a fun problem, that people use as kind of a test. So if you ever look at the foo bar problem, you'll find some similar implementation of this. And so if we run this and start from the top, so we should have started at 1 because 0 is technically divisible by all of those, but if we skip that and go through the rest, so 1, 2, foo. So when the I reached 3, we went through the if else blocks, and 3 modulo 3 is obviously 0. 3 is divisible by 3 with a remainder of 0. We logged foo, and that's our case there. 4 isn't. Bar is number 5. So if the number is divisible by 5, we log bar. And the next one, 6. 6 is divisible by 3, so it's foo. 9 is divisible by 3, so it's foo. 10 is divisible by 5, so it's bar. 11, 12 is divisible by foo, or by 3, so it's foo. And then finally I reach 15. 15 is the first number that's divisible by both foo and bar, so it ends up being foo bar. So that's a contrived example and a common one. It's meant to show you that you can do a bunch of code in here. So, and it could be anything. And when we learn about arrays, we will use for loops to loop through arrays, and you might have a certain condition inside your array that you're trying to meet. So while you're searching through the array, if you find something, you might do some sort of code. But for now, just remember these things. For loops consist of a variable declaration at the beginning and an assignment. Doesn't necessarily have to be 0. It could be 1, 2, whatever, based on your code, but most often you'll see it start at 0. it's got to go to some sort of condition. So whether that's greater than or equal to or less than, some sort of condition goes in the middle. And finally, an update to your variable so that you get closer to breaking out of this condition. So for loops they need to be limited so you don't have an infinite loop, just like the while loop. So thank you for watching, and I'll see you in the next video.